One variety on the differential equations involving f is equal to ma is when you're asked to set up your own differential equation given a pair of conditions. So for example, you might be given force and time, a pair of forces and a pair of times, or a pair of forces and displacements. And what I'd suggest to do is to draw a graph of the two of them. So if in a question you were given when the force is equal to 5 newtons when the time is 1 second, and then later on the force goes to 10 newtons when the time is 6 seconds, if you plotted that, you would get the graph on the screen with the two dots there. You draw a line through them, and then what I'd suggest is to get the equation of a line. So I'm using y is equal to mx plus c here. You could use y minus y1 is equal to m into x minus x1, whatever works for you. Well, when you get the equation of the line, we'll see that the slope is 1, it cuts the y-axis I think at 4, and that's the general equation of the line when the x-axis is labelled x and the y-axis is labelled y. But in this case, the x-axis is labelled time, so I'm going to say it's the t-axis, and the y-axis is labelled force, I'm going to say it's the f-axis. And that means in my equation of a line formula, I now have a relationship between f and t. Typically, we don't integrate f, so I have to leave f is equal to ma. I would divide under by the m, and then a would be equal to 1 over m times t plus 4 over m, and you'd be given the mass. And then you can solve the differential equation as you would usually, using dv dt or something like that. Now here's a second example with it. If you are given information with regard to the force and the displacement, so let's say the force is 5 newtons when the displacement was 4 meters, and then later on the force was 10 newtons after the particle moved 2 meters away, so the displacement is 6 meters. Again, you'd plot a graph. But in this case, we'd plot displacement against force. Now, what I've assumed in both of these is that the independent variable is displacement, goes on the x-axis, and the dependent variable goes on the y-axis, which is the force. If you get these mixed up, it's fine, just so long as you rearrange your equation of the line with a on its own on the left-hand side before you integrate it. But let's get back to this one. You would draw a line straight through it. You'd apply some equation of the line formula. I've worked out the values for m and c there myself. You would do that yourself. And then on the y-axis we have the force, so F. On the x-axis we have displacement. I've just left it as x for displacement. Again, you'd have to leave F equals ma on the left, divide under by the m, whatever value that is, and that would give you an equation with a on one side and x on the other. And then you'd make a substitution v dv dx on the left-hand side for the acceleration. Okay, let's set up two questions. Actually, set up one question, and I'll leave you work away with the second one. So if we read this in the textbook, a particle of mass 12 kg moves along a straight horizontal plane, along a straight line, starts from rest. So that means its velocity equals 0 when its displacement equals 0 and its time equals 0. There are initial conditions. Particle is subjected to a force away from P, which starts at 6 newtons. So that gives us, when the displacement is 0, the force is 6 newtons. It then increases uniformly, and then when we reach a displacement of 10 meters, the force works out as 24. We want to show that that formula is indeed true for the acceleration. So I've plotted my 2 points on the graph. I draw a line through them. I apply whatever equation of the line formula you use. I know the c value is where it cuts the y-axis, so that's equal to 6. And I've calculated the slope as well to be 18 over 20. Of course, on the y-axis there's f, the displacement is on the x-axis, and then f is equal to ma. Instead of m, I'd put in the 12 kgs, divide under, and then when we simplify it, a should work out as 10 plus 3x over 20 meters per second squared. You should then be able to finish off the question yourself. So pause the video and finish it. I'll move on, and then will you do this question also? Okay, that's the end of the video.